Okay, hello everyone. Let's try to continue the PSKoans series. We'll stream for, I don't know, about half an hour. See how many we can do. Start with AboutStrings. So we're currently at 58 out of 279 Koans. So we're slowly getting there. Okay, so strings. Strings in PowerShell come in two flavors, standard strings and string literals. Standard strings in Posh are created using double quotes, whereas string literals are created with single quotes. Unlike most other languages, standard strings in PowerShell are not literal and can evaluate expressions or variables mid-string in order to dynamically insert values into a preset string. Okay, so describe strings. It is a simple string of text. So blank should be a string, so just copy it, and string should be string. So we move into context literal strings. So it assumes everything is literal. The dollar variable equals some things you must take literally. So with single quotes. So some things you must take literally should be var. And literal strings can contain special characters. Special is just the title. So they have $, or colon, or semicolon, or underscores. So complex var should be just the same text. And it can contain quotation marks. These are quotation marks, you see, so single quotes go more easily in double quoted strings. What are we after here? So this will just cancel everything, won't it? Yeah. Or is this allowed? Is this? Let's run this and see what this ends up as. That was a weird notation. I haven't seen before. Oh, so they cancel them. Oh, nice. So you use the single quote to escape single quotes inside the literal strings. So, but if you do a double quoted string, let's do this. See, there are so many things with PowerShell that you never get into in a normal. Yeah. So yeah, use single quotation marks in a double quoted string, which you can escape them. You can escape them actually with a single quote within a literal string. I did not know. Okay, so we move on. Evaluated strings. It can expand variables. So var apple. Yeah, in an evaluated or double quoted string. So my favorite fruit is var. Let's do that in just a literal string then, like they've typed out. Oh. Did I miss? There we go. Control C is probably a good idea to hit, and then apple as well, and they've a space in between, so it will be a space in the string as well. And evaluated strings can do simple expansion. Your home directory is located here, home. So we just cut that out. and we paste it. And it handles other ways of doing the same thing. So strings can handle entire sub-expressions being inserted as well. So here is a string, your home folder is, and then $ parentheses, and then you put the entire sub-expression in there and end it with a parenthesis. So if we run this sub-expression, we will get this. So how will this actually look in a string? Will it just use the... Oh. Okay, so it will just use the name. The full name, I would say. Okay, and it can escape special characters with backticks. Yeah, letter A is apple, and then string is $, letter A contains letter A. So in this case you escape the $, with a backtick, so it won't expand or evaluate the expressions within letter A of the variable. So this would actually be a literal string like this. Okay, it can escape quotation marks. Yeah, so you can escape quotation marks in the same manner as you escape any other special character with a backtick. But you can probably, yeah, okay, so you can use the same trick as you did in the literal string by doing a double quote to escape it as well. So here you would get, this is a string value, and I would assume that you would get the same thing in the other line as well. VS Code tries to be smart with me and remove both. That's not what I wanted. And let's move on. It can insert special characters with escape sequences. So all text strings in PowerShell are actually just a series of character values. Each of these values has a specific number assigned in the char type that represents that letter, number, space, symbol, and so. .NET uses UTF-16 encoding for char and string values. However, with most common letters, numbers, and symbols that the assigned char values are identical to the ASCII values. ASCII is an older standard encoding for text, but you can still use all those values as is with char and get back what you'd expect thanks to the design of the UTF-16 encoding. An extended ASCII code table is available at asciicode.com. So here we have an expected value of char 9. So you typecast the number 9 into a char. So if you're sure what character you're after, consult the ASCII code table above. Get help about special characters. We'll list the escape sequence you can use to create the right character with PowerShell's native string escape sequence. So char 9 is space. Let's see what the get help about special characters says. Oh, lovely. Wait, what? Why does it try to run get VM switch with get help? Well, anyways, yeah, okay, let's just move on. So the char 9 is space, so in this case you'd want actual value to be this. So let's see if we got that right now. So let's run some measure karma. Yeah, so you probably need the backtick to... Do you need a backtick to escape? No, you don't. So this will fail now, because it probably should be this. No, it just failed on... Did I forget the... Yeah, of course I did. I forgot the... Yeah, what's that called in English actually? I can't remember. The dot? Yeah, let's call it the dot. Let's run Mashikarma again. Where were we? Here. So this would just be, yeah. So why would they escape the underscore? I don't know. So here we go. So line 97 is here. So it was not right. Expected. Oh, is it a tab? So how do you... So we would need the get help about special characters. So yeah, let me just run that in another window then. I wonder why it needed get VM switch to run get help. Or better yet, just find a browser. Where did it go? So a vertical tab is, yeah, okay, so it's well, horizontal tab is escape T, backtick T. So that's what we need then. There you go. Let's measure this then. So we could use either char 9 or backtick T to get tab in the string. Let's see, yeah, so we were right now. Okay, so let's move on. Context string concatenation. It adds strings together to become one. This string is cool. So we add them together with another literal string in between containing a space. So in this case, this string is cool would be the result of this. Okay, but it can be done simpler. So you can combine them within double quotation as well, or an evaluated string. So substrings lets you select portions of a string. Few things require the entirety of the library. At the very top, substring 06. So this would mean start at index 0 and just the 6 next characters. So this is 0 and then 1, 2, 3, 4, 5, 6. So this should be at that. And the substring with only one number is assuming, I think that's just assuming a start at index 0, so then it would be at the with space at the end as well. Let's measure this because I'm not 100% sure. So how long have we? 30 minutes, yeah. Is there any more? Yep. Please wait a moment. No, it's 127 is this one, yeah. So substring 7 assumes the last 7 then. 1, 2, 3, 4, 5, 6, 7. But that wouldn't be, or it's at start at index 7. 1, 2, 3, 4, 5, 6, 7. Yeah. 0, 1, 2, 3, 4, 5, 6, 7. Yeah, start at index 0 and all the way to the end. Okay, hair strings. Hair strings are a fairly common programming concept, but we have some additional quirks in PowerShell that bear mention. They start with the sequence at single quotation or at double quotation, and end with the matching reverse double quotation at or single quotation at sequence. The terminating sequence must be at the start of the line, or the string will not end where you want it to. So it can be a literal string, in this case with the single quotation marks, and will behave, I guess, as a normal literal string. So hello, and terminating it on the beginning of the line. It cannot be indented, yeah. So literal string should be, yeah, so it would be all these 1, 2, 3, 4, 8, 12, and then hello. Four, 8, 12, hello. And it can also be an evaluated string. So the key is in the patterns. Number equals something blank. These can mess with indentation rules, but have their uses nonetheless. I agree. String equals an evaluated here string. I am number, and something should be string. So we can select the number ourselves, 5 then. And I am number 5, exclamation mark. And it allows use of quotation marks easily. So all your quotes, all things that are not evaluated are recognized as characters. Yeah. So you can put them in here, but we need, in this case, to escape them. So let's measure. This takes some time. The keys and the patterns. I'm assuming, as most people would probably put number 1 there. Okay, so we're done. 73 out of 279. Let's move on to AboutStringOperators. See how long that takes. AboutStringOperators are there. Okay. String operators. While the standard comparison operators can be used with strings, there are also several operators that work exclusively with strings. The string operators are above. You have equal and not equal, so these are the same, greater than or less than. and it will compare the string sort order. Greater, less, or equal will also compare the string sort order. We have the F for format. We have the square parentheses to find the index. You have the sub expressions, the join, replace, split, and match, no match as well. So string comparisons work a bit differently to other comparisons. Rather than comparing the value of data, the strings are sorted, and the result of the sort determines whether a given comparison returns true. In other words, AB less than BZ is true because the first string comes before the second in a simple ascending sort. And equals and not equals works basically as expected, which would be comparing them and evaluating if they are equal or not. Unless specified, all operators are case insensitive. To make a given operator case sensitive, prefix it with the C. So you have the C equals, C replace, and C match, for instance. So this one is going to be interesting. I always muck up all the string comparisons when I write code myself, so let's see how this goes. So it tells whether the strings are the same. So if you have string, this is a string, and other string, this is a string. In this case, we compare them. String equals other string, and they will be true, since equals will not care about case. But in this case, we use the C equal, and there's a uppercase T in other string, so this will be false. It is useful for straightforward comparison. String is one more string, other string is one more string. So string not equal to other string will fail, will be false because they are the same. But if you do a case sensitive not equals, it will be true because they are not equal. Context greater than and less than tells you where the strings are in a sort. So string my string and other string your string. String greater than other string will be, so M is before Y, so what did we say here actually? If you use less than, okay, so greater than would mean later in the alphabet, so this would be false. And string less than other string would be true because this is before in the alphabet, so this would be true. String array operators. So this is the context of split operator. The split operator is used to break a longer string into several smaller strings. You can utilize either a regex match or a simple string character match, but defaults to regex. See get help about split for more information. So it can split one string into several. So hello fellows, what a lovely day. If we split it on the blank white space, it should be this hello and then fellows. What a lovely day, and it will remove the split character. And it uses regex by default. So hello there, split by the dot, be hello there. And it can limit the number of substrings. So planet split by the comma and 4, I would assume it picks the first 4. So Venus, Mercury, Venus, Earth, and Mars. And it can use simple matching. So hello there, split over the dot and 0. Simple match. What would this end up being? We got one too little. Oh, okay. This I don't understand. Because it would be the same if we just did that, wouldn't it? No. Ah, because it's regex, so you need to tell it to use simple matching. Okay. Because a dot in regex is basically 0 or more of anything, I think, and then plus is 1 or more of everything. And it can be case sensitive. Apples A are a totally a awesome. And do a case sensitive split on the uppercase A. So in this case, it would be apples are totally awesome. Okay, and then the context join operator. Join is used to splice an array of strings together, optionally with a separator character. It comes in standard and unary forms. So you have string, comma, string 2 join with the white space, double white space. No, so space separator would be string 1, string 2. If you do a join with string 1, comma, string 2 in the parentheses, it will join them without any space. So, and we can use get help about join for more information. And it can join an array into a single string. So array is hi there, what are you doing? And you put the array as input with join, and the separated character is space. So you do hi there, what are you doing? And it always produces a string result. So even if we have an array containing the characters or integers, it will create a string out of them. So this would be 1 3 6 7 1 9 2 2 1 3 4 5 5 6 7 8, because we haven't specified any separator characters. And it can join with any delimiters, so you can create your own delimiter or separator character. So this is so embarrassing, and here we have an ow and a space, so we need this entire thing. This is a nice feature of VS Code where it marks out everything that's the same, so you can see already that this is the separator character used. So context index operator, it lets you treat strings as char arrays. So here we go, string, beware the man eating rabbit, and we want the character on index 5, so 0, 1, 2, 3, 5, which is an R. It can create a char array from a string. So we have a string which is good luck, and we want indexes from 0 to 3. So that would mean G, O, and a D in the end. So that would be index 1, 0, 1, 2, 3. And it can be combined with join to create substrings. So here we have Mountains are merely mountains, and in this case we would like to join string and index 0 through 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and it would end up in mountains. So let's measure this before we end up on regex operators. Let's complete the regex operators and then we'll end the stream, I think. Please wait a moment while we examine your karma. Here we go. So we have an error on line 100. On line 100? Wow, that's early. Aha. So it will actually just split using the separator, but if you limit it to 4, it will just split the first 3 and then do the same together, or the rest together. Okay, so, well, makes sense, I guess. Okay, let's measure more. Measure again, see if we can move on to regex. I think we should. We can read the regex in while we wait here. Regex is a fairly complex language that doesn't read well. The examples here will be fairly straightforward. If you're not already familiar, check out regexer.com and play around with the example patterns given and try some of your own. In this section, try to enter a string that matches the given pattern using the explanations of each pattern on the website above. These operators return either... okay, so yeah, we'll try. Regex is quite hard to read, actually. Yeah, I agree. So 110 was wrong as well. 110. Is this line C split A? What did I miss? Did I forget them? These exclamation marks are killing me today. Let's try it again. These operators return, so match and null match using regex. These operators return either true or false, indicating whether the string matched. So now we're ready to move on. I think we're line 145. No, we messed up even more. 145 is this. Did I count wrong? Expected R but got E. Wait, what? Oh, yeah, you got E. Yeah, so 0, 1, 2, 3, 4, 5. Yeah. I apparently can't even count. So string is something, and we should match anything, any character from A to Z. So, but in the next one we should not match XFD. So if we put in C, we should be okay. So these are character sets in regex. The square parentheses. How about now? 189 is the next. Yeah, so that's the next one actually. So this was correct as well. Okay, and it can store the matched portions. So string should be something, and if string matches, and I believe this means that I can't remember this. Does this mean? Well, we actually got. We should have now. Oh, it's okay. So we should match A to C, and then number 4, and then it will store whatever is in the squiggly parentheses. So A4 should be okay here. So if I'm right, there we go. And oh, it doesn't like that. This is a problem with multi-line stuff in VS Code. It's a bit annoying. So we can use $matches to access any regex matching we've done. So we did not match anything. So this does not match. Okay, let's read this website. I can never do the regex right. You think you have a bit of control on it, and it doesn't work at all. Let's see if we can get regexer up and running. So we have this. So let's do the regex that we have, A to C, and then squiggly 4. So what? Ah, so it's 4 of the preceding token. Okay, so, well, I thought that was something else. There you go. So we need 4 A's then. And then we can go to this, and we oh, still no matching. Where's the, there we go. So now it's true. Okay. Why doesn't it print matches 0? Oh. Ah, result. Okay, 1, 2, 3, 4. So there we go. So the squiggly parentheses is multiplications of the preceding object. And it supports named matches. So regex uses the name pattern syntax to name a portion of a matched string. So string is something, and we here we match the first word with A to C, and plus means one or more of the preceding. So we can put in A, and so we can write 2 words like this, and then we should get this true, and then the first word should be 2, and the second word should be words. So we've given them names. and it supports indexed match groups. So when selecting match groups and named groups, the first group is at index 1 and the entire matched portion is still at index 0. Okay. So this string is 1298-something-0000, and the pattern should be 4 numbers and a dash, and then 3 numbers from 0 to 5. So we can remove this, and we can do 1, 2, 3, 4. So this should match. And then matches 0 would be the entire thing, and matches 2 would be 2, 3, 4. So let's measure before we move to context 2. Okay. Replace also utilizes regex to change the input string similarly to the string method. Replace $A$B, it will replace every instance of the found pattern in the given string. So it can, did we get it right? 229 is the next, yeah. So it can be used to replace individual characters. String is keep calm and carry on. The pattern is and the replacement is something blank. So we should have the string and we should replace pattern and with the replacement, and then should be keep calm and carry on. So we can put in the ampersand. Okay, and it can be used to remove specific characters. Polish the granite boy, and the pattern is either A, E, I, O, U, or if it starts with any character from A to C. So replace pattern, and it should be, so let's see. So it will remove the first character of each word and any vowel, I would assume. So P, I, and then the T would be removed, and the E, and the G, and the A, and the I, and the E, and the B, and the O, and the Y. See if we got that one right. And this, if we can hit it. Okay, so it would be only lowercase a to c. No, not even the first letter. So what would this do then? BY, so not any vowel. And I don't know why, I don't understand why the white spaces got removed, so let's check this in the regexer page. What does it match? So AI, so that's case sensitive, so that's okay. And a boolean or, and a negated set. Aha. I thought, so if the hat is on the beginning of a line, it means that it needs to begin with it, but if it's inside a set, it means that it's negated. So then it will remove, okay, so let's do that one more time then. Because then it will remove A-E-I-O-U and anything not a character. Or a letter at least. So O will be removed, I would be removed, SH will not, the white space will, TH won't, the E will, the white space will, GR, the A will, N and the I will, T and the E will, and the comma will, and the white space will, and the B will not, and the O will be, and the Y will not, and the exclamation mark will be. Okay. So that means a negated set. And it can be used to isolate specific portions of a string. So we have a string which is called account number and 0281.3649.8123. So the pattern should be so /w means any letter, I think. So one or more of any letter, white space one or more of any letter, colon, white space, and then /d means digit, and four digits, and an escaped dot, and 4 more digits, and a dot, and 4 more digits. So, and the replacement is $1, $2, $3. So yeah, so tokens are regex variables, not PowerShell variables. So we need to take the string, replace the pattern with the replacement. So remember, the first match is, well, the index 0 would be in the entire match. And so it would, but would it, so the parentheses assigns the matches you want to keep. So in this case it would be the first set of numbers, space, and the second set of numbers, and the space, and the third set of numbers. Oop. Okay, so the last topic is formatting operators, and the context is a string formatting operator, which is the -f, uses the same formatting parser as the .NET method string format, allowing for more complex strings to be constructed in a clear and concise fashion. I'm not sure I agree with clear and concise, but that's my 2 cents. So it allows you to insert values into a literal string. So string hello, $, and then 0 with squigglies. My name is also so something, yeah. So name is, so if we put in Tom, and string format using the name, so it will just basically mean that you would replace these with the value that you want to format it with. So this should end up as hello Tom, my name is also Tom. So if you want more of these, yeah, you put it in an array behind the F operator. It can insert multiple values with formatting on each. So here we have employee number 1, and you want it to be 1, 2, 3, 4, 5, 6 digits. So this is index number 1 in the array that you want to format over. So you want, in this case, index 1, but you want it with 6 digits. You are due in room number and then index 0 with 3 digits for a drag test. Okay, that's harsh. So in this case, you would have employee, so index 1 is index 0, index 1, so employee number 19. You're due in room number and then index 0 with 3 digits, but so that is 154. It already has 3 digits, so no need to put in any zeros. And a sub-expression operator for the end of string operators. The sub-expression operator, this one, is used to insert complex values into strings. Any valid PowerShell code is permitted inside the parentheses. So it will convert any object to a string. So hello user 1 through 10 should be this would evaluate first, so I guess we would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is necessary to insert object properties into strings. So object get item home and the object parent. So it would get the parent of this. Let's just evaluate it. So this is the parent of the item, and in this case, why is this star? My keyboard has changed again. There we go. So, and dot parent is users, and dot full name, I guess. So it would be this. Oh, no. So this would be and this would be C users. It's a trick question because it won't. You need the sub-expression operator to resolve any children of the object or any methods or any attributes of the object or any children of the object. Yeah. So let's measure karma. No. Before we give up. So we had some wrong. We have on line 280. So why does it put a space between them? Is that just some quirk of, because when you do this and then two string it, no? Okay, so we'll just insert the string. Well, nice to know. Would that apply to any array? Yeah, it would. Okay, nice to know. Nice to know. So, now we should be done. No, still not. Okay, so it will not do a full name of it. It will just do this. Okay. Well, great. So no one is injured but by himself is the wisdom word of today. Great, thanks. Well, this measures again. Thanks for watching if you watched it, and I'll see you next time, I guess. Just wait to see if we're done. No. Oh. There we go. About conditionals is the next one. So, see you later. Thanks for watching.